This video is on the properties of logarithms. There are three major properties you must learn and be able to manipulate. First off, log base A of mn, the product mn, equals log base A of m plus log base A of n. With numbers, it looks like this. Log base 2 of 4 times 2 will break into log base 2 of 4 plus log base 2 of 2. Let's do the arithmetic on this and verify that this really is true, and then I'll explain why this works. Log base 2 of 4 is 2 because what you're saying is 2 to the second power equals 4. Same thing here. 2 to the what power gives you 2? 1. So this side would equal 3. If I did this arithmetic here, which is 4 times 2 is 8, I'm looking at log base 2 of 8. What is the log base 2 of 8? Meaning what is the power that goes on 2 to make 8? 3. So that verifies that this works. So in words, we have the log of a product, which is what this is. It's the log of a product equals the sum of the logs. Notice whatever base this is has got to be the same base that you use over here. It doesn't matter what this is. It's just got to be the same thing over here. So this is worth memorizing. The log of a product equals the sum of the logs. Now, why does it work that way? Remember that the logarithm is the exponent that would go on the base to give you that number. Since the logarithm is the exponent, that means we're really dealing with the exponent laws. Since the exponent law for something like x squared times x to the third tells you to keep the base and add the exponents, that's the basis of this. Because these are exponents we're dealing with, we add those exponents. This next one is the exact opposite. Log base A of m over n becomes log base A of m minus log base A of n. With some numbers to verify, I did log base 3 of 27 over 3. According to this property, it should break into log base 3 of the top, which is 27, minus log base 3 of 3, which is the bottom. Log base 3 of 27 equals 3, because 3 raised to the third power is how we get 27. Log base 3 of 3 is 1, because 3 raised to the first power gives us 3. So this side gives us 2. If we do this arithmetic, we have 9 here. So this side is talking about the log base 3 of 9, which equals 2. In words, the log of the quotient equals the difference of the logs. The log of the quotient, which means divide, equals the difference of the logs. This is silly, but it might help you. Think about this line of the fraction bar becoming this line of the minus. Now, two ways to explain why this works. One is it's the exact opposite of the property about product. Since the log of a product was the sum of the logs, since the quotient is the exact opposite of product, then we're talking about the opposite sign here. That's why it's minus. But the bottom line of why this works, it's the exponent laws. The exponent laws for doing something like x to the third over x to the second was a matter of keep the base and subtract the exponents. Logarithm of something is dealing with the exponent. Third property is the power property. This says log base A of m to the n. Very simply, the n, which is the exponent, kind of like dislodges and comes down in front of the word log. So now we don't have any power at all. This n, which used to be an exponent, has now become a coefficient. And in solving log equations that we'll do later, you'll see how important that is. As far as numbers go, log base 5 of 5 squared. I brought the 2 down in front, and that's how this became 2 times log base 5 of 5. Well, log base 5 of 5 is 1 because 5 to the first gives me 5. 2 times 1 is 2. This is one of the identity properties we had a while ago. Log base 5 of 5, remember, as long as these two things agree, then this side is just equal to the exponent. This one, in words, is the log of a power, is the product of the logarithm and the exponent. The log of a power is the product, meaning we're going to multiply that exponent times the logarithm. To show you why this one works, I'm going to use the property that we had in the beginning. Log base A of x squared is the same as log base A of x times x, which according to the first property breaks into log base A of x plus log base A of x. Well, if you add one of these plus another of these, you end up with 2 log base A of x's. which is exactly what's going to happen if I take that exponent and dislodge it and bring it down to become a coefficient. So that explains to you why that property works. Now let's do some problems. Your directions will say use the properties of logs to expand each logarithm expression as much as possible. In other words, that says you cannot have the logarithm of a product, a quotient, or of a power. So we're going to use those three properties we had a couple minutes ago and do some expanding on this. The first thing you should do when you see log base 2 of something is take a look how many letters you have. That's how many times you're going to have to write out this log base 2. This is going to be log base 2, slide over a little bit, log base 2. Because it's a product, the sign that goes in between these two log words is plus. Then go back, it's a product, there's your x, and there's your y. That was your first property. The log of a product equals the sum of those logs. Another simple one with the same set of directions. I have log base 3, which I'm going to write twice. And the reason I'm writing it twice is because I have two letters. In between here is a division sign, which we said converts to a minus between the logs, and x, which is the top, goes first, and y, which is the bottom, goes second. 3 variables, so I'm going to have to write out this log base c 3 times. I'm leaving a little bit of space in between there for my x's and y's and z's, and for whatever symbol I'm going to use. Notice this is a product and a quotient going on at the same time. Well, just look at the product, xy. Pretend that's all you had. Well, that's going to be log base c of x plus log base c of y. But notice where the z is. The z is in the bottom, meaning it has been divided, so this becomes minus log base c of z. A little bit different problem. I still have 3 things, but notice I have 2 things in the bottom, and there's 2 ways to do this. What I think is the easiest way, first off, is what I've said already. You've got 3 variables. You need to write log base 5 3 times. If you had 8 different variables, you would have to write log base 5 8 different times. So get that started. Then look in terms of up and down. The x is up, so it's going right here, and it's considered positive. Both the y and the z are underneath. They are being divided. Therefore, they both get a minus in front of them. A common mistake is for people to write log base 5 of x minus log base 5 of y plus log base 5 of z. But if you put the plus here, that's implying that this and this were multiplied together, which would have put the x and the z both in the top. So what I think is the easier way to go is just to think about where it came from. If it's in the top of a fraction, it's positive. If it's in the bottom of a fraction, it's negative. Now think about your exponent laws. Remember something like 1 over x squared converted to a negative exponent? Same idea. If it's in the bottom, it's going to have a minus in front of it. Now we've got some powers. If all you have is one letter to that power, just grab hold of that power, bring it down in front. And this becomes 5 times log base 2 of x. This next one, we've got 2 letters with a power also. We've got to think about this being log base 3 of a product first. So I'm going to write log base 3, log base 3. I'm only writing it twice because I only have 2 variables. This is a product between the 2 of these. So between this and this, there's going to be a plus. So it's log base 3 of x plus log base 3 of y squared. That's only dealing with the product part. But this power right here is going to have to be dislodged from here and brought down in front. So I'm going to bring this 2 down in front here and then just scribble this out or erase it. And that's going to be your expansion of this expression. You need to think of this radical as exponent. Think about this being x times y to the 1/3. Remember, the cube root is the same as y to the 1/3 power. So now this is log base 3 of those multiplied together. We have 2 variables, so write this log base 3 twice. What's happening between these? This is a multiplication, which converts to a plus. So the x is going to go here, and the y to the 1/3 goes here. but we can't leave it with a power, so we dislodge this power, we bring it down in front, and we can either erase it or just scribble it out. How many things do we have inside here? We've got 3. Notice also this just says log, but we know log is the same as log base 10. That doesn't mean you have to write base 10. I'm just pointing that out so that you don't think, hey, wait a minute, I'm missing a base. You're not. It's log base 10. But I have 3 variables, so I'm writing this word log out 3 times. Then I have to decide up and down. This y to the 5th is up, so it's positive. This x squared came from the bottom, therefore it's a minus. The z came from the bottom, therefore it's a minus. The only thing is now, I still have these powers to deal with, so wipe out that 5, bring it down in front to make it become a coefficient. Wipe out the 2, bring it down to become a coefficient.